On November 24, 1944, the skies above Tokyo witnessed a pivotal shift in the air war. 111 Boeing B-29 Superfortresses of the U.S. 73rd Bombardment Wing took off from the Mariana Islands, including Saipan, Tinian, and Guam, as part of Operation San Antonio, targeting the Musashino Aircraft Factory, a key producer of engines and fighter planes for Japan. This was the first major air raid on the Japanese capital from altitudes most Japanese aircraft could not reach, quickly demonstrating that aerial warfare had entered an entirely new era. The B-29s flew at an operational ceiling of 33,600 ft, approaching their technical maximum of 40,600 ft. This altitude created an extremely dangerous gap for Japanese pilots flying fighters like the Mitsubishi A6M0 or Nakajima Ki-84 Hayate. Even Japan's most advanced aircraft struggled to operate effectively above 30,000 ft, especially when fully loaded with fuel and ammunition. In this environment, the B-29s hovered over Japanese cities, seemingly completely out of reach of both Japanese pilots and anti-aircraft defenses. The first shock came from the realization that what the Japanese had once dismissed as American propaganda, that the B-29 could fly at unprecedented altitudes and ranges, was actually true. Japanese pilots, trained in the samurai tradition, had long believed that courage and skill could overcome technological disadvantages. Now, they faced a harsh reality. Courage cannot outperform physics. The B-29 was not merely a bomber, it represented a technological leap, an integrated weapon system that Japan had never developed. A key factor in the B-29's superiority was its pressurized cabin. Equally crucial was the R-3350 duplex Cyclone engine system with turbochargers, one of the most important technologies on the B-29. The turbochargers maintained engine power at high altitudes, where thin air would otherwise severely reduce performance. This meant the B-29 could still climb, maintain speed, and remain maneuverable, while Japanese aircraft could barely operate effectively. The turbocharging system used exhaust gases to compress intake air, allowing engines to maintain optimal power even above $35,000 ft. Another feature that made the B-29 so dangerous was its centralized fire control system. Turrets were controlled by analog computers that automatically calculated firing angles, adjusting for altitude and distance to the target. This system allowed one pilot or gunner to control multiple turrets, creating a coordinated network of fire that Japanese pilots could only confront from below, the only altitude they could reach. Combined with its high operational ceiling, this made the B-29 nearly impossible to shoot down with conventional Japanese aircraft. The November 24, 1944 raid also marked the first strategic shock to Japan's air defenses. Radar detected the 111 B-29s from 200 miles away, and Japanese fighter squadrons were scrambled, only to immediately realize they were attempting an impossible climb. Most Japanese planes could not reach the required altitude. Those lucky enough to approach the B-29's ceiling quickly faced engine overheating, loss of control, and fuel shortages. In practice, even aircraft with theoretical ceilings above 36,000 ft could not operate effectively due to poor quality fuel and lack of turbocharging. The B-29's high-altitude capability was not merely a tactical advantage or accident, but the result of long-term U.S. strategy and massive infrastructure. After capturing the Marianas in June 1944, the U.S. could deploy B-29s to strike any Japanese city, turning a once impenetrable island nation into a vulnerable target from the air. The B-29 program cost $3 billion, more than the Manhattan Project, and each plane was a testament to the technical prowess of American industry. What set the B-29 apart was how the U.S. integrated technology and organization. More than a bomber, the B-29 was a complete system, with engines, cabin, firepower, navigation, and crew organization functioning in harmony. This made it a war machine capable of operating in areas inaccessible to the enemy, a concept now known as domain control or air superiority. Meanwhile, Japanese pilots watched helplessly as B-29s flew above them. They were forced to confront the painful truth that skill and courage alone could not overcome physics and technology. This shock was not just a tactical defeat, but a profound psychological experience, foreshadowing the decline in morale among Japanese pilots and civilians in the following months. This raid also paved the way for later U.S. campaigns. By exploiting the B-29's high ceiling, they could conduct daytime raids, nighttime low-altitude operations, and even atomic bombing missions without facing effective Japanese air resistance. All of this demonstrated that modern warfare no longer depended on individual skill or fighting spirit alone, but on industrial capacity, integrated technology, and organizational efficiency. Another key point: the B-29 was not only technologically advanced, but also a symbol of American industrial might. Each plane required over 13 tons of aluminum, half a ton of copper, nearly 600,000 rivets, more than 9 miles of wiring, and 2 miles of tubing, produced on advanced assembly lines Japan had never possessed. While Japanese planes were still partially hand-built, the B-29 was mass-produced, standardized, and maintained quality at scale, allowing the U.S. to deploy thousands of modern aircraft simultaneously. The first shock experienced by Japanese pilots facing the B-29 was not just about a plane, but about how warfare had fundamentally changed. Watching American aircraft hover at unreachable altitudes, they realized that war had become a contest of industrial and technological capability rather than skill or bravery alone. This was the moment the best samurai warrior era gave way to the era of industry and technology, with the B-29 as its vivid symbol. When the U.S. B-29 Superfortresses first appeared over the skies of Tokyo at the end of 1944, Japanese air defenses immediately realized they were facing an entirely new and unprecedented challenge. This was not just a matter of conventional tactics. It was a technological and psychological crisis, where no matter how courageous Japanese pilots were, they could not overcome the physical limitations of their aircraft. First, consider the climb capability of Japanese planes. Core fighters such as the Mitsubishi A6M0, Nakajima Ki-43 Oscar, and Nakajima Ki-84 Hayate had theoretical ceilings ranging from 33,000 to 36,000 FT, but that was under optimal conditions with light fuel and minimal armament. In practice, when fully loaded with fuel, bombs, and ammunition, their effective ceiling dropped sharply, often to only 25,000 to 30,000 FT. This meant Japanese pilots struggled to reach the operational ceiling of the B-29, which was 33,600 FT, and even maximum climbs caused engine overheating, loss of aircraft control, or forced retreats before reaching the target. A key factor weakening Japanese air defenses was fuel and engine quality. By late 1944, Japanese aviation fuel had deteriorated significantly, often only 87 octane compared with the 115 octane used by the U.S. for the B-29. Poor fuel quality caused engine knock and drastically reduced high-altitude performance. Furthermore, Japanese engines lacked effective turbochargers, losing power quickly when climbing, in contrast to the B-29's turbocharged engines that maintained maximum output even above ceiling altitude. In addition, pilot support equipment severely limited high-altitude operations. Without pressurized cabins, Japanese pilots had to wear oxygen masks continuously, endure extreme cold, and cope with prolonged hypoxia, which impaired focus, slowed reflexes, and sometimes caused loss of consciousness. Cockpits were unheated, and flight suits offered inadequate protection, creating an environment far harsher than that experienced by American crews, giving the B-29 a complete physiological and technical advantage. This disparity quickly created a tactical crisis. When Japanese radar detected B-29s at a range of 200 miles, fighter squadrons were scrambled, but most encountered immediate problems during the climb. Overheating engines, severe speed reduction, limited maneuverability, and dwindling fuel. Those fortunate enough to approach the B-29 ceiling only had a few minutes to engage before being forced to retreat. In many cases, Japanese pilots could not get close enough to shoot down the B-29, and the risk of crashing or dying on the return flight was high. Recognizing the futility of conventional interception, the Japanese were forced to innovate extreme tactics. From August 1944, ramming attacks began. Pilots deliberately collided with B-29s to destroy them, an extremely dangerous but sometimes effective tactic. The 244th Sentai, led by Captain Terahiko Kobayashi, was one of the pioneering units organizing planned ramming attacks. On December 3, 1944, they claimed to have destroyed 6 B-29s using deliberate collisions, with all pilots surviving by bailing out after impact. Yet even these extreme tactics addressed only a small part of the problem. Most B-29s continued their missions unaffected, proving the issue was not the pilots but technological inadequacy. Japanese high-altitude aircraft projects, like the Mitsubishi J-2M Ryuden or Kawasaki Ki-108, with pressurized cabins and turbocharged engines, never entered mass production due to limited materials, technical challenges, and operational complexity. Only a few prototypes were tested, and most were incomplete before the war ended. Additionally, the shortage of professionally trained pilots worsened the situation. As the war progressed, pilot training was cut from 2 years to a few months to compensate for losses, producing inexperienced pilots unable to execute complex high-altitude interception tactics, leaving the B-29 nearly invulnerable. Another factor complicating matters was the jet stream exploited by the B-29. Japanese pilots could not fly high enough to study or utilize these strong winds, while American crews learned to use them to increase speed and conserve fuel. When intercepting B-29s, Japanese aircraft had to climb against the wind, reducing speed and maneuverability, whereas the B-29 flying with the current faced minimal impact. All these factors combined to create a state of desperation for Japanese air defenses. They could not prevent the raids, and had to witness pilots attempting interception but failing, returning with damaged engines, exhaustion, or even dead. The psychological shock spread, lowering the morale of both military forces and civilians, as no pilot or skill could protect the cities from B-29 attacks. This led to a comprehensive crisis in Japanese aerial warfare. Aircraft were not high enough or powerful enough to intercept B-29s. Pilots were inexperienced or inadequately equipped. Poor fuel and engine quality caused rapid loss of aircraft power. Lack of pressurized cabins and anti-cold gear fatigued pilots and reduced combat effectiveness. Traditional interception tactics failed, necessitating extreme measures such as ramming. This crisis impacted not only the pilots, but also the overall air defense strategy. Military leaders had to reconsider defensive capabilities, but limited time and resources, combined with U.S. industrial dominance, made improvements only temporary. Many pilots realized they were fighting an asymmetrical war where courage and skill could not compensate for technological and industrial inferiority. Japanese efforts to develop new high-altitude aircraft largely failed. Units such as the 244th Sentai, 343rd Naval Air Group, and other high-altitude interception groups faced severe declines in aircraft quality and pilot numbers, allowing B-29s to operate freely over Japan. While the U.S. enjoyed complete technical, altitude, and organizational superiority, Japan fell into an unchangeable position. The initial shock of the B-29's high-altitude presence quickly turned into a psychological disaster. Japanese pilots experienced several stages of emotion, skepticism, and disbelief. Initially, many pilots thought reports of the B-29's high ceiling were American propaganda, unable to believe a plane could operate above 33,000 FT and remain combat effective. Frustration and helplessness. After multiple squadrons failed to climb sufficiently, pilots realized no tactics could overcome the altitude gap and that engaging the B-29 under current conditions was nearly impossible. Extreme tactical innovation, suicide ramming attacks, experimental high-altitude aircraft with turbochargers or pressurized cabins were attempted but limited and too late to alter outcomes. Acceptance of technological inferiority. When temporary measures failed, pilots and leaders acknowledged the technological dominance of the U.S., a major shock to a culture that relied on skill, courage, and fighting spirit to compensate for material shortcomings. Industrial and logistical crises worsened the situation. Many aircraft suffered engine failure or lost maneuverability during climbs, but repairs were impossible due to a lack of parts, tools, and skilled engineers. By spring 1945, available fighter aircraft had fallen below 40%, making B-29 interception nearly impossible. The psychological pressure extended beyond pilots to civilians. Witnessing cities bombed without effective resistance eroded national morale and confidence in air defenses. Particularly, the jet stream and high-altitude weather further disadvantaged Japanese pilots. B-29 crews used strong winds to boost speed and save fuel, while Japanese aircraft climbed against the wind, reducing speed and opportunities to attack. The jet stream not only reduced bombing accuracy for B-29s but also increased operational distance and fuel strain for Japanese planes. The combination of physical limitations, outdated technology, resource shortages, and psychological pressure rendered Japanese air defenses virtually ineffective. Efforts to improve, from turbocharger experiments to pressurized cabins and ramming tactics, had only limited effect, unable to change the reality that B-29s flew freely over Japan with almost no opposition. When the U.S. conducted daytime and nighttime bombing campaigns, Japan could not respond effectively. Nighttime incendiary raids in March 1945, for example, showed that Japanese fighters could no longer protect cities. Over 300 B-29s destroyed more than 25% of Tokyo, while U.S. losses totaled only 14 planes, mostly due to weather rather than combat. Japanese high-altitude aircraft projects like the Mitsubishi J-2M Ryuden or Kawasaki Ki-108 represented a last-ditch attempt to match the B-29, but only a few prototypes were produced. Turbochargers and pressurized cabins were unreliable. Even if complete, poor fuel and pilot skill still limited interception ability. By early 1945, Japanese pilots gradually accepted they could not stop the B-29, and defending the homeland became a massive psychological burden. Confrontations were no longer battles, but struggles against physical and technological limits. Training and maintenance collapse prevented a new generation of skilled pilots. Training programs were shortened from 2 years to months, and inexperienced pilots could not execute complex high-altitude tactics. Advanced fighters required precise maintenance, but lack of tools, parts, and engineers led to aircraft failures, even causing pilot deaths during climbs. Throughout the B-29 campaign, Japan had to accept that no individual bravery could bridge the technological gap. Each B-29 integrated multiple advanced technologies: turbocharged engines, pressurized cabins, automated fire control, and mass production. In contrast, Japanese planes were limited in number, technology, and pilot skill. The result was a total crisis for Japanese air defenses. B-29s flew at unreachable altitudes. Japanese planes lost power at high altitudes without effective turbocharging. Pilots suffered from cold and hypoxia. The jet stream hindered climbing attempts. Poor fuel and logistics made high-altitude operations exhausting. Insufficient pilot numbers and inadequate training. All these factors created an extreme aerial warfare crisis, leaving Japanese pilots unable to protect cities and civilians, causing severe psychological impact and eroding national morale. From a tactical perspective, the U.S. maximized its technological superiority. B-29 squadrons could choose timing, altitude, and flight paths to optimize bombing effectiveness and minimize risk. Japan, still resisting, was forced into unconventional tactics, such as suicide ramming, but with limited success. Crucially, The B-29 did not just alter Japan's air defense organization, it changed the perception of aerial warfare, demonstrating that technology and industry, not individual bravery or fighting spirit, were decisive. This crisis set the stage for later bombing strategies. Japanese impotence against the B-29 established precedents for air campaigns with absolute altitude and technological superiority, integration of technology, organization, and training over individual tactics, recognition that industry and logistics underpin modern warfare. By early 1945, Japanese air defenses had completely collapsed. Experienced pilots were either killed in action or incapacitated by illness, shortened training programs produced inexperienced pilots, and most advanced fighters were no longer capable of reaching the altitudes required to intercept B-29s. This meant that U.S. bombing campaigns proceeded almost unopposed, opening a period of devastating destruction against Japanese cities and industry. One of the first major raids in 1945 was the Tokyo operation on the night of March 9-10. 334 B-29s flew at low altitudes, between 5,000 and 7,000 ft, to maximize the effectiveness of M69 incendiary bombs, causing a massive firestorm. Although flying lower made the American planes more vulnerable to attack, Japanese air combat capability was almost zero, so losses remained very low. Only 14 B-29s were lost, mostly due to atmospheric phenomena such as air turbulence and fire whirls, rather than enemy fighters. This raid destroyed 267,000 buildings and killed roughly 100,000 civilians, clearly demonstrating that the U.S. had near-total air superiority over Japan. Strategic bombing continued to target factories and critical infrastructure. For example, the Nakajima aircraft factory at Musashino was repeatedly attacked, preventing Japanese aircraft production from fully recovering. Oil refineries were also destroyed, severely reducing aviation fuel output, the lifeblood of any air force. As a result, even potential Japanese interceptors were unable to perform high-altitude missions or sustain prolonged combat due to fuel shortages. Ships and railways were also affected. B-29 raids, synchronized with U.S. submarine blockades, paralyzed domestic supply chains, causing shortages of food and materials for both military and civilians. Bombing densely populated areas further undermined civilian morale, demonstrating that air warfare was not only a military assault, but also a psychological weapon. A key factor in the B-29's effectiveness was the integration of complex technology. More than a high-flying aircraft, the B-29 was a complete combat system. R-3350 turbocharged engines maintained high power at extreme altitudes, whereas Japanese engines lost power rapidly when climbing. Pressurized cabin, U.S. crews operated comfortably without oxygen masks, while Japanese pilots endured extreme cold and hypoxia. Centralized fire control system. An analog computer calculated firing solutions, allowing B-29s to defend effectively against attacks from below. Mass production. Each plane required over 13 tons of aluminum, half a ton of copper, and hundreds of thousands of mechanical components. U.S. industrial capacity allowed large-scale production and maintenance, while Japanese aircraft were still partly hand-built, insufficient in quantity and quality. These elements gave the B-29 a decisive technical and strategic advantage, making it a symbol of American industrial dominance in the war. When B-29s flew over Japan, it was not only pilots confronting physical limits. Japanese society experienced a cognitive shock. Courage, skill, and willpower were no longer enough to defend the nation against superior technology. By April 1945, when P-51 Mustangs from Iwo Jima began escorting B-29s, Japanese pilots' survival chances were virtually zero. The P-51s had the range to escort B-29s across Japan, eliminating Japanese pilots with minimal U.S. losses. In one engagement on April 7th, The U.S. claimed 101 Japanese aircraft shot down while losing only 2 P-51s and 7 B-29s, demonstrating absolute technological and tactical superiority. Continuous, coordinated B-29 campaigns left Japan no chance to recover its forces. Experienced pilots had dwindled, and newcomers had only a few hundred flight hours, insufficient for high-altitude combat. Maintenance issues, poor quality fuel, and spare part shortages rendered advanced aircraft virtually useless. Combined with nighttime bombing tactics and incendiary attacks, B-29s destroyed Japanese industry, cities, and civilian morale, forcing Japan to focus on survival rather than combat. The impact of the B-29 extended beyond physical destruction. It highlighted that airspace control. American aircraft operating at altitudes unreachable by Japanese forces ensured total air dominance. Technological warfare superiority. The B-29 proved that integrated technology and industrial production determined war outcomes, rather than solely fighting spirit. Psychological effect. Japanese civilians and pilots realized that personal bravery no longer mattered in a conflict with such a technological gap. Key U.S. targets, including the Nakajima factory at Musashino, oil refineries, infrastructure, and residential areas, were heavily damaged. Destruction escalated over time. February 1945, 172 B-29s destroyed 28,000 buildings with incendiary bombs. April 2, 1945, over 100 B-29s attacked Nakajima Aircraft Factory. April 7, 1945, 101 B-29s attacked the same target again. April 13, 1945, more than 300 B-29s attacked military targets around Tokyo. These raids not only crippled aircraft, fuel, and equipment production, but also devastated transportation, ports, and material distribution networks. It was a comprehensive campaign, integrating air power, naval operations, and intelligence, creating pressure Japan could not resist. The final atomic bomb missions on Hiroshima, August 6, 1945, and Nagasaki, August 9, 1945, were merely the continuation of a campaign that had already exhausted Japan. Every B-29 flying above 30,000 ft unchallenged was proof that strategic air control belonged to the U.S., and the atomic bombings were the final confirmation of Japan's total failure. When Japan surrendered, industrial output had fallen below 15% of its peak, the population was exhausted, and morale had completely collapsed. The B-29 was not merely a weapon, it was a symbol of industrial dominance, integrated technology, and modern war strategy. Beyond strategic impact, the B-29 left a lasting legacy for global aviation. The Soviet Union studied the B-29, influencing the Tupolev Tu-24 high-altitude design. Future nations developing fighter aircraft and air defense systems focused on high-altitude interception and surface-to-air missile systems. Modern warfare demonstrated that industry, logistics, and technological integration mattered more than individual bravery in large-scale conflicts. The B-29 campaign over Japan was not merely a series of strategic bombing raids. It established a new standard for modern warfare, demonstrating that technology, industry, and strategic organization mattered more than any individual factor. When Japanese pilots first witnessed B-29s flying above the maximum altitude of their fighters, they faced not only a physical challenge, but also a strategic and psychological shock. This technical superiority reshaped perceptions of warfare, industrial power, and the role of individual pilots in a world where technological gaps could determine the fate of a nation. One of the most important lessons from the B-29 campaign was the value of battlefield control. This concept emphasizes that operating in a domain where the enemy cannot intervene effectively provides a tremendous strategic advantage. Flying at altitudes between 30,000 and 33,600 ft, B-29s were beyond the reach of Japanese aircraft while maintaining combat capability. Although Japanese engineers attempted to develop new aircraft, experimenting with turbochargers and pressurized cabins, most efforts failed due to industrial limitations and fuel shortages. As a result, the B-29s did not merely fly higher, they dominated air combat completely, reducing Japanese pilots to powerless observers as American planes destroyed their homeland. Technological integration was the decisive factor. The B-29IS advantage did not come from a single technology, but from the coordinated operation of multiple advanced systems. R-3350 turbocharged engines maintained high power at extreme altitudes. Pressurized cabin allowed crews to operate comfortably without continuous oxygen masks, centralized fire control system with analog computers, coordinated automated fire across multiple gun turrets, precision electronics and navigation, enabled effective daytime or nighttime bombing missions. Combined with mass production, these factors made the B-29 a symbol of American industrial might. While Japanese planes were still largely hand-built, each B-29 was assembled to precise standards with hundreds of thousands of components, something Japan could not achieve at scale. The integration of advanced technology with industrial capacity ensured the U.S. could maintain continuous operations without concern for aircraft shortages, while Japan suffered losses in both materiel and combat capability that could not be replaced. The campaign also highlighted the importance of training and military organization. U.S. pilots were thoroughly trained to operate the complex B-29 systems from pressurized cabin management to coordinated fire control, enabling effective performance at maximum altitude and diverse mission profiles, including strategic bombing, nighttime bombing, mine-laying reconnaissance, and psychological operations. In contrast, Japanese training programs had been shortened from 2 years to only 3 months, leaving inexperienced pilots unable to perform complex maneuvers or reach the altitudes of B-29s safely. This demonstrated that technology cannot reach its full potential without well-trained personnel. Psychological effects were equally significant. Japanese pilots, trained in a samurai tradition, believed courage and fighting spirit could compensate for material disadvantages. However, climbing to 30,000 FT with overheating engines, frozen cockpits, and limited oxygen made clear that courage alone could not overcome physics and technology. Repeated failures in interception missions inflicted heavy morale losses, not just on pilots but on the civilian population, who witnessed the inability of Japanese aircraft to reach their targets and consequently lost faith in their nation's air defenses. The B-29 campaign also demonstrated that scale and strategic coordination were critical. B-29s did not operate alone. They were escorted by P-51 Mustangs from Iwo Jima, supplied and maintained from forward bases in the Marianas, and coordinated with submarine and intelligence operations. This created a multi-dimensional campaign, striking Japan from multiple directions while minimizing aircraft losses. It was a clear example of modern warfare thinking, where victory does not depend on isolated engagements, but on the integration of industrial, technological, and military capabilities. In the long term, the B-29 campaign reshaped global aviation and military strategy. The Soviet Union studied the B-29, influencing the Tupolev Tu-24 and emphasizing high-altitude, long-range capability. Nations developing fighter aircraft focused on air defense and interceptor missile systems to counter high-performance bombers. Even in the modern era, the principle holds: control of a domain that the opponent cannot contest confers a decisive strategic advantage. Another lesson was the power of industry and organization. Victory depended not only on pilot skill or bravery, but also on the ability to produce, train, maintain, and deploy complex technological systems. The U.S. demonstrated that a nation with advanced industry, complete logistics, and efficient organization could produce superior weapons and overwhelm the enemy both quantitatively and qualitatively. Conversely, Japan, despite courageous pilots and fighting spirit, could not sustain resistance due to industrial and resource limitations. The B-29 experience also left a lasting impact on Japanese aviation. Post-war aircraft designs and training programs emphasized high-altitude operations, long-range flight, and pressurized cabin technology. The experience of being left behind under the B-29 became a crucial historical lesson, guiding generations of Japanese engineers, pilots, and strategists for decades. Finally, the legacy of the B-29 was not merely about aircraft or bombs, but about how technology could reshape the entire course of warfare. Aviation museums often display B-29s alongside Japanese fighters to visually illustrate differences in size, technology, and combat capability. This serves as a vivid lesson. In modern warfare, personal courage and fighting spirit cannot compensate for technological and industrial disparities. The B-29 campaign also exemplified the strategic value of multi-domain warfare, combining air power, naval forces, intelligence, and industrial logistics to maximize effectiveness. No single element alone could achieve victory. Success came from synchronizing, integrating, and optimizing all resources. This principle underpins modern high-tech warfare, from space and air to cyber domains.